Okay, I guess those of you here who are here, can you guys hear me okay without the echo? Okay, good, thanks. We're just gonna wait a couple more minutes till everyone has joined in. I believe people from LO2 should also be in. So let's just give everyone a couple more minutes, and then we'll start. Okay, we can get started now. So just a few announcements. So App Project 2 will come up on D2L sometime towards the end of this week. Um, but I'll just let you know what it is. So App Project 2 is an open-ended project. It's up to you to sort of design a project based on any application you're working on. It could be a hobby project, it could be a capstone design project, it could be a research project. So the project is open-ended. The end application that you want, it's up to you. The only requirements will be you have to use a certain fixed number of peripherals. So you should be using clock switching and power saving features. You should be using communication with the computer, using Python, and or the terminal. Mostly, yeah, you will be expected to use something to do with Python. So, and what else? Yeah, you should be using resets like, watchdog timer resets, brownout resets. So these are going to be fixed peripherals, fixed drivers that you should have. In addition, you should use 3 or more drivers. So your project should have all these drivers that you're using. So you should have a fixed number of drivers that I just talked about. But then you can use any other drivers, but you should make sure you have 3 or more drivers that you're using. So it could be applications like you can sort of implement an oscilloscope if you want your folks who are on the electrical side. You can implement a data acquisition card. You can implement an IoT sensor. You can sort of implement any sort of like a multimeter. So whatever that application, that's up to you. But we do require that you use a fixed number of peripherals, and then in addition, you should use at least 3 or more of the other driver level peripherals. But you will get more details when the handout for that is on D2L. But yeah, it's a good idea to get started on it, right? So next week it's the midterm break, and then after that, you have a slew of sort of projects coming to you, right? So you have app project 1 sort of coming to you. You have driver level 5 due. You will have maybe 1 or 2 more driver projects that will sort of go up as well. So in 3 or 4 weeks after the midterm break, you have 2 app projects. Hopefully you're close to getting done with app project 1, but you will have app project 2 and 2 other drivers, right? So make sure you sort of get a head start on them. The drivers aren't too bad, but yeah, make sure you get ahead with app project 2. And there are 3 of you in a group, so make sure you divide the labor properly, so as to get things done quickly and without any stresses. So yeah, with that, let me get started on the demo for today. So today we're going to basically get the microcontroller talking to Python, and we're going to do this demo in 2 parts. Part 1 is basically just getting them talking, sort of some sort of formatting on Python side, some cleaning up of data on Python side. You're dumping it into a CSV file on Python side, and how the format of the data that you're sending from the microcontroller affects that. So we're going to talk about that. And part 2, we'll talk about some more features in Python that can sort of be helpful when you're sort of implementing things like data acquisition and stuff like that. So before we get started on the Python programming, let's have a look at what's sort of happening down at the physical level of UART communication between the 2, right? So on one side, you sort of have your PIC microcontroller, and on the other side, you sort of have your PC, and you sort of have data going that way. So that's going to be your TX on this side, and your RX on this side, and I think just to be accurate, you sort of have a USB to UART module. So that's what's sort of happening, right? And so what's happening is every time you sort of use the xmit UART2 function, so say you have xmit UART2, and you're sending, say, a number 5, and you're sending it one time. So what's sort of happening on this bus is you're basically sort of sending 8-bit, or you're sending basically characters from the MCU to the PC side, right? And so the data that sort of is being sent on that bus basically is something which is between 0 and 7, so it's 8-bit wide. And what you're sending is the ASCII code for 5, which is, I believe, 0x35. So it's 5 plus 0x30. That's basically the ASCII conversion, or the ASCII equivalent of number 5. Right? So that is basically 35. So that's 0, 0, 1, 1, and 5 is 0, 1, 0. Right? So you're basically sort of sending this, from the MCU to the PC side, and each of these bits gets transferred at 9.6 kilobits per second if you're using 8 megahertz clock, 4,800 bits per second if you're using a 500 kilohertz clock, and about 300 bits per second if you're using a 31 kilohertz clock, right? So that's how the data rate comes into play, right? And so you're basically just sending 8 bits. You're basically sending characters from the MCU to the PC, right? And so if you have, if you're sort of using other functions, for example, if you're using xmit-ur2 say G only once, then you're basically sort of sending the ASCII equivalent of G, which I don't know what it is, but I think it's UX50 something, yeah. So you're basically sort of sending that 50 something. I don't remember what the number is, but you're basically sort of sending the ASCII equivalent. And then you sort of have other functions that you're using. So for example, if you're sending disp to des, if you're sort of sending a decimal value, and say you're sending 65,000. Right? So what it's doing is it's still using xmit-ur2, but you're sort of breaking this up, and you're sending ASCII equivalents of individual sort of digits in this number, right? So basically what you're sending is the first thing to go is basically 6, which is basically 0x36, and then you basically sort of, so that is the 6 that goes first, and then the next that goes is 5, which is 0x35, and then you basically have a bunch of zeros, so that's 0x00, that's the 0 here, and then you sort of have running out of room, but you're sending 0x00 and 0x00 corresponding to these last two zeros. So you're basically sort of sending the most significant bit, bit first, followed by the rest, right? So you're still using xmit-ur2, but in the basic form, you're basically sort of sending 8-bit characters from the microcontroller to the PC side, right? And so on the PC side, you're basically sort of receiving all these characters, and you're sort of having to sort of clean it up, handle, and sort of manipulate the data to display it in equivalent form as to what you're sending from the microcontroller, right? And so questions on that so far? Oh, yeah, okay. Thank you, Ben. Yeah, so G is 0x47. So this is actually 47, right? And then if you're sort of sending disp to string, double quotes, hello. So basically, when you're sending that, you're basically sort of sending the ASCII equivalent of H first, which I don't know, 0x40 something. You're sending the ASCII equivalent of E, which is also, I believe, 0x40 something. And then you're sending the ASCII equivalent of 0x40 something. So this is H, this is E, this is L, this is L, and this is O. So all you're sending basically is sort of ASCII equivalents of all the characters, and you're basically sending it in 8-bit character form. And so moving to my computer. Okay, so I'm sort of using Spider. I'm using Python 3.8. You can sort of use any sort of IDE that you want, that you're comfortable with. And so basically, before you start using it, you sort of have to install a few modules, right? And so some of the modules that you're going to be using is you're going to be using NumPy, basics, the NumPy, math. And so you want to make sure you import them, but make sure you so first sort of download those modules using a pip install command in the terminal. Right? And so in Spider, it just looks like any other IDE. This is where your code goes. This is sort of where the variables that you're using, they show up here. And this is sort of the output terminal window, right? And so you sort of have to import a few modules. So we're going to be using import NumPy. You're going to be using NumPy. We're going to be using map. You're going to be using CSV. Since we're going to be dumping data into CSV, we're going to be using serial. And we're going to be using some time delay based functions. Right? And so if you want to install serial, make sure you sort of do, I think depending on whatever ID you're using, the command to type out here in the terminal is pip install PySerial. Or if you're sort of using Conda or Anaconda, I believe it's Conda install PySerial. Yeah, so to make sure you install serial, you'll need that. Why am I getting this unintended indent? Yeah, okay. So yeah, make sure you keep track of all the indentations. Will this work using Jupyter? Yeah, it should work using Jupyter as well. Yeah, any ID it works. As long as it's compatible with serial, it should work, right? Most of the other ones, NumPy, Math, Time, they're sort of built in. They're sort of, they're workable on any sort of Python. So we're going to be using these modules. We're sort of going to be using serial strings and lists to sort of receive the data coming in via serial to clean it up. And then once it's in a list form, you can sort of move it to a NumPy array or a data frame. That's entirely up. And whatever we're doing here, there are a number of ways to do that. I'm just sort of using the basic lists to clean up and sort of format all the data. But you're free to use, 3 or 4 other methods that you can use when you're using Python. So you need this on Python side. And the way to sort of get data via serial is you have to use the serial module. In that there is a serial function, and what this does is S is capital here, and what this does is it basically sort of opens the serial port, and whichever port you want to open, it depends on what that COM port gets labeled as. In my case, the port basically gets a value of COM4. On the microcontroller side, we're going to be using an 8 megahertz clock, and so the baud rate we're going to be using is 9600. If you remember, when we were sort of setting up the UART, we're basically sending out data or character in 8 sort of bit size, and so the byte size we're using is 8. This can be 9 as well, but we're going to be using 8. We have the option of setting a timeout time. So basically, what this timeout means is if the port is open and if no data is received in 2 seconds, basically it just sort of stops receiving any data. Right? So the timeout is 2 seconds, and the stop bits we use are the standard stop bits that come with UART. So it's serial dot stop bits underscore 1. So what this does, this sort of opens the serial port. And so before we go any further, we should get the microcontroller started, have it sort of start sending data over. And so I'm going to open up MP Lab alongside. And so if you can sort of see what I have in MP Lab, I'm sort of using the same function that I was using for the UART demo. Let's see if I can. Yeah. Okay. And all it is doing is it's got a main, a bunch of initialization, and I'm basically sort of sending xmit UART2 a counter plus 0x30. So counter is something that increments from 0 to 9. I'm adding 0x30, converting it into its ASCII form, sending it once, sending a gap after that, space after that, just incrementing the counter. Right? So it basically just goes through this while loop infinitely using this while one loop, and I'm just basically sending numbers 0 to 1. And so I'm going to program it. I'm going to run it. So I have the hardware set up here, and so that's already connected to the computer using USB to UART, and it's basically going to start sending values 0 to 9. And it's always a good idea to verify that the transmission is occurring correctly. And so the way sort of I do that is I just sort of open up teraterm or real term, and I just sort of do a new connection. In my case, I'm using COM4. I hit OK, and you will see it's sort of the PIC is basically sending data, right? In some cases, you will notice when you first time connect the USB to UART, the first time it sort of sends out a bunch of garbage. And that basically happens when there is an incorrect handshake between the USB to UART module and the PC. And so, if you want to fix that, just hit program again. It'll basically take care of that. And so make sure this is happening. But once you verified it in teraterm or real term or any other terminal window, make sure you disconnect before you move over to Python. Right? If you don't disconnect, Python will not be able to open the serial port while real term or the terminal is also sort of accessing the UART port. So we've sort of gotten the transmission started. That's happening now. So now let's sort of start getting data from the COM port using Python. So that basically opens the serial port. Next thing we sort of need to do is we need to sort of read the values that are coming in. So there are a number of ways you can read it. Python lets you capture a fixed number of bytes. That's the easiest way. And so the command for that is s is equal to ser dot read, and we're going to read 100 bytes. So we have created an object ser. It's assigned to the COM port, and we're going to sort of use that object to read 100 bytes coming in from the serial port. And so what this does is it reads incoming 100 serial bytes. And so once you've received 100 bytes, always make sure you close the COM port. If you don't close this COM port and if you run this program again, you will sort of get a message saying that you cannot open the COM port, it's already in use. So make sure whenever you have an open serial port command, make sure you have a close serial port command as well. And let's see what we've received so far. So the value coming in, it's basically the data received is stored in S. And so we're just going to do a print S. Let's see what this looks like. So if you notice what's received is basically received a bunch of numbers. It's basically received 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's gotten space in between each of those characters, and it's basically saved in byte form. And so if you sort of want to double check, just type S, and it shows that the values received are in byte form. So you have to sort of, so basically what is received is 0x35, 0x34, 0x31, 0x30. And so you sort of have to convert this into ASCII form. And so the way to do that is basically use, we're going to sort of use scare to store the string, the decoded string, and the command for that is s.decode ASCII. So we've taken this value in byte form and we've converted that into sort of ASCII form. And to verify what it is, what that looks like, we can sort of hit play again. So it's gone back, it's captured 100 bytes in byte form, converted that into scare form. And so scare looks something like that. It's a single string with all the bytes it's received, with 100 bytes it's received. But keep in mind, the 100 bytes also include the spaces in between. So it's about 50 characters or 50 numeric characters and sort of 50 or so spaces. And so you sort of have space in the beginning. And so you sort of have to clean this up. You will be splitting it up. And then you'll be sort of dumping it into a CSV file. And so we need to sort of clean this up, and so we need to clean up the gaps in the beginning. We want to clean up the gaps at the end, and so the command to clean that up for a string is basically we're going to do scare. We're going to sort of use that to also store the cleaned up string. And we're going to use scare.strip. And so basically what this does is it basically sort of removes any sort of spaces or if you have a /n or a /r as the first character, it will basically clean that up, or I think remove that from the beginning and the end of the string as well. And so let's see what that looks like. So I'm going to capture 100 bytes again. And so this is in byte form. This is in character form. And then I think, let me just type scare again here. So previously there was sort of a, well, this time it didn't capture a space. So whether you capture a space or a /n or /r, it depends on, it depends on sort of what's being captured the minute Python opens the port and gets it. Right? Sometimes it'll sort of, the first thing it captures is a gap. Sometimes it captures the character itself. Right? So in this case, this time around, it basically just captured the character. So this wouldn't have been necessary, but in general, it's always a good idea to have this to remove sort of any gaps or /ns or /rs at the beginning or the last capture. And so this cleans it up. The next thing we need to do is we sort of need to break this up into individual elements and basically save it in a list. And we're going to sort of use scare still to sort of store the converted list. And so we want to sort of break up, this is one string, we want to break it up into individual characters separated by space, right? And so to do that, the command is scare dot split. And we want to split it by the space or the gap in between. And so that's going to be in single quotes, just a space. And to see what that looks like, so let's see if I can pick a better example. Yeah, is this better example? No, I think even this time it captured the first thing was a character. Okay, so this is a good example here. So I've captured 100 bytes, and the first thing it sort of captures is space. when we sort of do the dot strip function, it gets rid of the space here, but it's still stored as an array of, it's still stored as a string. And so we need to break it up by its individual string elements or characters. And so that's sort of done here. And so this is what we have in the end, right? So right now, at this point, we sort of have a list, and what's received. It contains 50 sort of characters that were received. The 100, the sort of the space characters that were received, we've sort of removed them by using the split sort of function. So this is what we have, and now we will sort of want to take this, and you want to sort of you can sort of move it into a data frame. Once it's in a list form, you can move into a data frame. You can move it into an array, and you can sort of store it, sort of if you want. And so in our case, it's a good idea to convert it into NumPy array so that you can sort of do mathematical operations. But observe that the elements of the list are characters, right? And so we need to convert each of these elements in the list to its individual int form or float form, or whatever form you want. And so that's pretty. For that, we just sort of do let's convert into numeric form. So let me call the list, of these characters converted to numeric form as snum, and I'm going to sort of use a for loop. But what do I want to do for each element in skchar? I want to convert that into int. And so what this will do is just a for loop that basically goes through each of these elements in the list and converts it into integer form. And so if you see what this looks at, so previously we had a list containing characters, and now we sort of have a list containing just numbers. And then once it's in this form, then you can convert it into an array. You can convert it into a NumPy array. You can convert it into a data frame. That's entirely up to you. So in our case, let's convert this into a NumPy array. And I'm still going to use the variable snum to hold the numerical array. And the way to convert a list into array is np.array. And just we're going to why am I getting across here? np.array. Oh, it's equal to sign missing. And so if you print what snum looks like here, so it took this snum previously, which was a list of numbers, and it's converted that into an array form. And so NumPy arrays are good in the sense that if you want to use it, I don't know, like most of us, we started out with MATLAB, but if you just want to sort of multiply all the elements at once without using for while loops, or whatever, it's always better to have them in array, NumPy array form. Lists, if you want to sort of multiply each element by a fixed number or add or do any mathematical operation with each element, you sort of have to use a for or while loop to do that, right? But with NumPy arrays, you sort of do what you do when you use MATLAB, you just multiply it. So it's always beneficial to convert any lists of numbers or characters into NumPy arrays, right? And then once it's in NumPy array form, you can just basically save it in CSV or text format, and the command for that is np.savetxt. You can sort of write this into CSV file. Let's call it UART data 5 dot or let's call it, I have a few other things I was listing out, 6.csv. And what we want to convert, what we want to sort of dump in the CSV file is the NumPy array snum. And we want to set the delimiter as commas or spaces. In our case, we're using a CSV file. So we're just going to use delimiter of comma. And if you sort of run this, it will create urdata6.csv in the same folder where I have this code residing. And so drag that over. So it created urdata6 and it's basically saved everything, the received characters in numeric form in the CSV. Questions? Let me just hold off and see if there are any questions. So yeah, Ben already answered this, but if you have no F close, so I've been sort of hitting play continuously, right? And the only reason I can do that is because there's a serial close here. If I don't have a ser.close, what would happen is it won't let Python open the port again because it has the port open from the previous time. Right? Any other questions? Give me 1 second. It was easy. Converting it to NumPy was easy. Once it's in NumPy, converting it into data frames, CSV, or any of the format becomes very, very easy. But we could sort of do that because in our case, the received data was all in numeric form, right? But this won't work if you sort of have if you also the microcontroller is sending alphabetic characters in addition to numeric characters, right? Then this conversion into NumPy array line will give you an error, right? And so what would happen if you sort of have you sending your numeric characters in ASCII form, and what happens if you sort of have you sending a bunch of characters, alphabetic characters with the numeric characters, right? And in this case, let's see what happens. In this case, you obviously cannot use NumPy arrays. You sort of have to use other ways of storing the data. And so when I program this, to see what it's sending, let me just open up Terraform again. Let me just, so it's sending numbers and it's sending UFC. So if I hit disconnect, so yeah, it's sending 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 UFC. And so I've disconnected it. Let's see what happens when Python tries to receive it. So in this case, I sort of get an error. And the error is something to do with, using inform. You're sort of having a character and trying to convert it into inform. So, it could be this line. Well, this line will still work. Yeah, you could sort of do an is-digit check to see if it's a number or not. But I don't think this line is a problem. Yeah, this line is the problem. So, I'm trying to convert a character into inform, so I'm getting an error here. But also, when I sort of try to convert an array which has alphabets and numbers, this line will give me an error, and even this line will give me an error, right? Because NumPy arrays, from what I understand, can only save numbers or alphabets in an array, like separately. But it can have an array with numbers, or it can have an array with alphabets, but not the same, not both in both, right? And so if you sort of have a situation like this, then you sort of have to sort of use a workaround. In other words, what we can do is, so at this point, we are still sort of receiving. So SKR, right up until this point, we are sort of receiving the bytes correctly. But you sort of have this U here, you have this UFC here. So you're sort of having numbers and alphabets, right? So there is another way to save this into CSV files, but you can also do that without using NumPy. You can just sort of write the list that we received like this directly into the CSV file. And so let's see, the way to do that would be, what do I comment out here? So I still need this. I still need the serial port. I still need the decoded ASCII string. I still need to clean up any gaps in the beginning and the end. I also need to split them up based on the space in between. So everything till here is useful. But I'm just going to comment out this part. So I sort of have this. And what do I do with this as scare? So I need to add, so this is basically a single list from left to right containing all these characters. If I want to say, so if I want to save it as rows in a CSV file, I need to sort of add a /n, a new line at the end of every sort of character, right? And so to do that, let me just use scare still, and I'm going to sort of take every element in scare. And I want to sort of add or attach /n at the end of it, right? And so the command for that is lm plus /n, which is new line. So let's see what this does. So it took the list that I had before, and it just sort of attached the /n at the end of every character received. And so then I can sort of just take this, and I can sort of directly write this into a CSV file. Right? But if you're sort of taking, it's easier to write strings into CSV than lists into CSV. Who knows? There may be a way to write lists into CSV directly, but I don't want this square bracket at the beginning of the end, right? And so I can sort of, the easier way would be just convert this list of characters into a string again, and then just use the file open command to write this string into CSV. Right? And so the command for that would be scare. I'm still going to use scare to save this list of characters as a single string. And the command for that is single quotes space dot join scare. And so what this does is I print what scare looks like at this point. So this is what it was before. So this is what was originally received. This is that in ASCII form. This is the list of that ASCII form. This is basically attaching the /n, the new line at the end of every character. And then when you have the /n, and when you sort of print it out as a string, it basically sort of converts that single sort of list into basically a single string. And so at this point, if I type scare, that should be a string type, a single string type. Yeah, so it's a single string, right? So it has a single quotation at the beginning, a single quotation at the end, but a bunch of /n's at the end. Right? And so now that I have everything in the form of a single string, writing it into a CSV becomes pretty easy. The command for that is, because we have an import CSV that we did at the beginning, the command to write it into CSV is file equals open. Type in the file where you want to save it. let me call it UART data. What was I using earlier? 6. Let me call this UART data 7.csv, and this needs to be in quotes. I want to sort of write into this CSV file, right? And so the mode is W. So this basically just writes to CSV. And then you just basically write the string into this. And so the command for that is just file.write. The string we're trying to write into that is skr. If you open the CSV file, once you're done writing it, you have to close it. And so it's just file.close. And so if you sort of run this, and if you run this, it should have created a UART data 7.csv file in the same folder where the code resides. And so yeah, so it's sort of created a CSV, and it has all the characters, the numeric characters. It also has all the alphabetic characters, right? And so yeah, if you're sort of using this method, you can also send strings like characters, alphabetic characters in addition to numeric characters, and sort of save it in a CSV file as well. Questions so far? So there's a number of things still. I mean, this is sort of the most basic way of sort of getting a bunch of characters from the microcontroller and dumping it. Here I'm sort of reading 100 serial bytes at a time. But you can sort of use any sort of trigger to start or stop the capture, right? I mean, in Python, it's an open source language. You can sort of have it start and stop captures at the press of a keyboard key. You can also sort of use time delays to sort of capture, or time intervals to capture sort of data bytes coming in from the serial. And so if you're sort of using any of those other methods, you can sort of use time. Time is a good way. And so if you're sort of using time, the way to sort of do that would be you sort of use the time module. And there's a way to sort of start time, stop time, and in between you can sort of capture the data. And so if you want to use time interval to capture data, so you still need this serial open port. You have to open that, but you don't need this. Let me just comment that out. So this is, let me comment this out. Here, capturing fixed number of serial bytes. But if you want to use then in this time module, you sort of have the option of having a start time, a stop time, and capturing time, capturing data in between, right? And so the way to do that is we first of all need to create an empty string, because in this case you're not capturing 100 bytes at once, but you're capturing individual bytes. And so for that, you will first have to create an empty sort of string to store the received characters. And then if you sort of use start time equals time.time function in the time class, so it's time.time. And so what this does, it sort of it captures the time when it gets here. And then what you want to do is you want to wait a fixed time interval, and during that time interval, you want to keep on capturing data. And so the command for that is while time.time minus this initial timestamp stored in start time is less than how many ever seconds you want. Oh, sorry. While time.time minus start time is less than 1 second or 5 seconds or whatever seconds you want. Let's do 0.5 seconds. While you sort of within 0.5 seconds, you want to capture serial data coming in. So the command for that is ser.read. So previously it was ser.read 100. Now it's just ser.read. And so this reads incoming single byte. And then once you have that, you want to basically capture each incoming byte. You want to save it and concatenate or append it to this string. And so the command for that is scchar equals scchar plus whatever we received. Keep in mind that's in byte form, so we have to convert it or decode it into ASCII form. And so it's s.decode ASCII. And then so once we've captured the incoming characters for 0.5 seconds, once we come out, what do you want to do? We want to close the serial port that we've opened previously, and then let's see what scchar looks like. Let's see if I hit run. Oh, I'm getting this message saying permission denied, and the reason for that is the previous time I have this Excel file open here that I'm writing into. So let me just store this in UR data 8. Let me hit run again. Okay, and so this time what it did is let's first look at what scchar looks like. So scchar is, these are all the bytes that, so these are not 100 bytes, these are more than 100 bytes, but these are bytes captured in a 0.5 second time window. And it basically does whatever we did before, and it saves it in UR data 8. So let's just verify that. Yeah, so it saved that as well. Right? So the difference between this time and the previous time is previously we were only capturing 100 bytes, but you can also sort of have it to capture data over time intervals of 0.5 seconds or whatever you. Okay, so with that, we're out of time. I'll go ahead and put this code up on, I'll post this code on D2L, and we'll sort of have one more demo to talk about, a few more Python features. We're out of time, but are there any questions? We can take a couple of questions before we break. Okay, if not, keep an eye out for App Project 2 and the next couple of driver projects on D2L. And so next week is we have a quiz on Friday, and then next week is the midterm break. So make sure everybody gets enough rest, and then we'll resume the week after. Okay.